Yes. Good morning, everyone. Yes, Vivek, I'm good now. Can wait for 2 more minutes, and then I'll start the session.
Good morning, ma'am. How are you doing? Are you feeling better?
Yes. Shall we proceed?
Yeah, yes, ma'am.
Yeah. Good morning, everyone.
Yeah, good morning, ma'am.
Good morning, all. Yeah, I'm good. Thank you all. Yes. Right. So this is a continuation of your context session 2, right? So in the module 2, we have discussed about the machine learning workflow and what are all the different types of learnings are available, and in which situation we are supposed to consider this as your this as a supervised learning and unsupervised learning, right? So we have discussed so many stuffs, right? Now we will start with the data quality. Okay, so in the last class we discussed about the role of data, the importance of data, and different types of data also we have discussed, right? Now, as per today's discussion, I'll proceed with the data pre-processing technique. So before that, you should understand the necessity for data, quality of the data, right? So what is data quality first, and how to improvise it, and what are all the mathematical techniques we are supposed to adapt before going to forward this information data to the model, right? All such stuffs will be discussed. After that, later I will proceed with the module 3, which is linear regression. Okay, yes. Now, so the data quality can be assessed based on these parameters. It should be correct, should be a correct information, it should be consistent enough, and it should be trustable, complete information, usable on demand, and it should be interpretable, right? So, okay, right. So as for today's plan, what kind of data quality problems are arises if you have a real world data set, right? So whenever in your hand, if you have a real world data set, you will face these problems. You will face these problems, right? And how can we detect the problems with the, but how do I know whether these all are the issues, right? How do you detect it? That is what our next discussion. And the third discussion is how can we do about these problems? How do you handle it? That is what our third discussion, right? So the examples of data quality problems are, it can be a noise or outlier. It can be a wrong data. It can be a fake data, there is a possibility of missing values. There is a possibility of duplicate values, right? Especially just consider this data set, right? We have a transaction ID, refund as one of the feature, marital status as another input feature, taxable income as another feature, and whether they cheated or not. That is what my target variable Y. So from transaction ID to taxable input can be considered as input variable X. Yes? Will you agree this? X is not, it's not necessary that X should be one feature or one column. It can be a multiple feature. So it's a subset of X is a nothing but it can be represent X1, small x1, x2, x3, x4, right? All such vector representation is comes under your input variable capital X and my target is cheat, right? Whether they cheated or not. Okay. Just observe this yellow color highlighted row. What is your observation? Please let me know. The transaction ID says 5 and the refund, no. Marital status is divorced and taxable income.
It's extremely high, madam.
Extremely high. It's extremely high. Yes. Whether it, because we don't know whether it is a mistake or maybe the person can be a millionaire, right? Yes, but we don't know. But in general, but we should not consider the exceptional case until or unless you have a ground truth. Okay. So in general, the generalization purpose, we will consider this as an issue. Yes, one issue we have observed. And what about the next one in the second, sixth and seventh row, sixth and seventh transaction ID? You can observe the null values here. Even in target also, you can expect the null value. It's not necessary that all the cells should be filled with a more appropriate data, right? So whenever we are trying to collect the data from real world, there is a possibility some missing values, right? This is called as null represents missing values and inconsistent duplicate entries. See here, the last two, transaction ID is same. It's not different. And refund, this value is also same, right? And what about this one? Married and single, but rest all other values are same. These two are nothing but inconsistent duplicate entries. If the entry, the transaction ID is different, for example, if it is 10, then it's not a duplicate entry. We cannot consider this as a duplicate entry. But for a single person, they have entered two different set of records. That is why you are getting same transaction ID. These all are the issues in the data, right? So whether your data is quality data, why we need first quality data?
To ensure our model
many
is
machine
trained
can
on
be
Sorry?
To train the model properly with the
To
correct
train the
data.
model. One nothing. It's very simple. What suppose if I have given wrong information in the live session, right? So whatever is suggested by the faculty, based on that understanding only, you will solve the problem in the exam. Yes. Will you get the correct solution if you have used the wrong formula? Because during class itself, I used the wrong formula. So based on my live session recording, what suppose if you have used the same approach for your exam point of view, will you get the good mark or correct the marks? No.
No.
So because of my mistake, you learnt wrongly, hence which reflects in your result. Yes. The same thing is applicable here. If the data quality, here formula is my input. What suppose if I have instead of plus, what suppose if I have given minus in my formula wrongly? It's a typo error, right? Because of this one small error, you will get different result. Your understanding itself, it's totally wrong. And you will get totally a different result in the final examination. So, which impacts your final mark, right? So if the quality, the data quality is not sufficient, if the data quality is not good enough, right? Then that is, if you are providing the wrong data for learning purpose, based on the wrong information, only model will try to learn it. Yes. Yes. Based on the wrong understanding only, it will try to predict the future unseen value. Hence, we will not get the promising result at the end. Yes. So that is why before going to forward your data to the model, right? Data cleaning is very, very important. Okay, yes. So the thing is the noise and outlier. There is a difference between noise and outlier. Noises are generally called as it's a extraneous object or see here we have a two sine waves, right? Without noise based on the time and the magnitude is represented here as a sine wave representation, right? Even this would be your observed signal, sum of the two sine waves. After observing these two signals, finally the consolidate one would be like this, right? Yes. What suppose if I have added some noise? Noise can be background noise at background traffic, right? So it could be anything, right? Some noise, if I added some add-ons, additional noise here, this smooth curve will become like this because this, it's far away from the deviating from the original environment. Yes, after adding the noise, right? So we should consider noise in our data, whether the data set has noise or not. Okay. And what about the outliers? Outliers are very simple. The marks column can hold 0. Is this applicable?
Yes.
88 or 95? Yes, of course.
Yeah, possible.
101?
It's still possible.
Not possible. What suppose if the total mark is 100? Out of 100, if you have
Marks.
evaluated,
Yeah, marks.
yes,
Not
out of 100, if you are evaluated, this is not at all possible. Negative minus 10? No.
No.
Right?
no.
So the outliers are the value should be with respect to by understanding the domain with the help of domain understanding, right? Each and every feature should have some range of values, that is 0 to 100, right? 100 and 0 are 0. These two are exceptional case, right? But we should accept those values 0 to 100. And if beyond 100 or below 0, all such values will be out of range. Yes or no? More deviating from the actual range. 101 or 110, these values are not aligned with my environment. Yes. So hence such data points are called as outliers. In this graph, in this picture, right? In this picture or visual representation, right? Almost all data points are grouped together, overlapped here. Yes. In this cluster, are you able to identify the outlier?
No, ma'am.
No. Here, still it's acceptable. Yes.
Yep.
This is also acceptable. This is also acceptable. What about this point, and this point? All these three are
Outliers.
outliers. Why? Because it's not associated or aligned with any one of the cluster. Yes, it's totally out of range, right? We cannot consider the distance is far away with respect to each and every groups. Yes, so such values are called as outliers. So we have to handle noise as well as outliers. We should remember this, right? Then how do you proceed with this? So we are supposed to adapt the data pre-processing technique. Let me explain the flow first. The pre-processing is nothing but we are trying to prepare our data. Preparing the data is called as pre-processing, right? Preparing our raw data we are converting our raw data into a quality data for ML models, right? Before going to forward such information, input information to your ML model, you should start preparing your data, right? So both data engineering and feature engineering involved here. What is the difference between data? What is the process of data engineering or the task here? The process of converting raw data into a prepared data is called as data engineering. I'll explain one by one, okay? And what about this feature engineering? see, which tunes the prepared data to create the futures. So, yeah, see, these all are a formal definition. I'll take one data set and then I'll help you how we can do the feature engineering and data engineering and all, right? Just as of now, preparation of prepared data is called as data. In data engineering, we'll prepare the data. Feature engineering, with the help of prepared data, it will try to create the futures, new features, right? Which are expected for the ML model. So raw data will be forwarded to the data engineering phase, and then you will be getting prepared data. The prepared data will be forwarded to the feature engineering phase. Then you will get the engineered features. This is what the most promising input feature. Now you can forward this information to learn our model. I mean, to make our model to learn. This is the flow. Yes, just read this case study. The BITS WILP is in collaboration with multiple IT companies interested to upskill and level skill their employees through inducting some stories, right? Over a year, yeah. Right? Semester and enroll in this. Okay, this is very important. Over a year of successful completion, the students are yet to complete another one semester and enroll in dissertation to complete the program with certification. Okay, yes. Students of similar academic background, irrespective of the time of enrollment, seems to score more or less in the same range in every semester. Okay, so accounting department requires to complete few academic year closure documentation for which they would have to build a collaborative organization based on the prospective number of students who might be eligible for project semester. What is the eligible criteria for enrolling the dissertation? Are you aware?
All 3 semesters.
Finish.
Students will be passed in all 3 semesters.
All 3 semester?
Students
guess-
should be passed.
Passed. Okay, we don't have any specific benchmark like 5.5 or 6 CGPA. No.
It is 5.5. ma'am.
5.5.
It's 5.5. You should retain this 5.5 for all the entire semester without arrear. Yes, for all 3 semesters. Then only you are eligible for enrolling dissertation, right? So we want to count
Yes.
that number. We want to predict, okay, based on your previous first semester and second semester record, right? Second semester record, we want to count for audit purpose or for accounting purpose. We want to predict how many students will be eligible for fourth semester, right? We want to predict this information, right? Yes. So these all are the attributes of interest. These all are available information from the record, from the raw data, right? Name, gender, age, date of birth, organization, job title, nature of job, entrance score, eligibility score, previous degree, WLP batch or not, whether the previous degree taken from WLP batch or not, section, ISM, these all are the subjects. Whatever subjects you have studied so far, everything can be listed here, subject marks, right? Yes, these all are the attributes of interest. Now, the main important question here is, we will again revisit this case study in the upcoming slides, right? The next important challenge here is, what suppose I have only 50 students record? Is it possible to predict?
Nope.
No, right?
No,
If you have at least past previous 5 cohort data, based on the pattern, and by adding these 50 students together, we can assess yes or no. Yes. So insufficient training data for learning purpose itself, we don't have enough sufficient. If you don't have enough sufficient data, then this is another challenge here. Yes, while doing the modeling. So what we are supposed to do? We have to trade off. Sorry.
Ma'am, how do you decide 50 is not sufficient or 500 is sufficient? Like, how do you take that call?
Okay, fine. So for learning purpose, we should provide as much as possible, right? I can explain the pre-processing. I'll give you one simple example. I can explain the pre-processing technique with the help of 2 slides. with the help of 20 slides. Yes?
Yeah. Okay.
Yes.
Yeah? Yes? Here, even see, even in this case, the explanation is not that much. I mean, I'm not going to explain in depth level, right? But if you have 20 slides of content with numerical examples and real-time case studies, then you will learn more.
Mm.
With the help
Yeah.
of two slides, will you learn whether you will learn more or not? Which one is better?
20 slides.
Second one. 20 slides.
Yeah.
20 slides are 20 slides. With the help of 20 slides, your learning curve will be increased.
Okay.
Yes. So same way, because data is input here. Data is input. Based on the data only, the model will try to learn the hidden pattern. If you have given minimal amount of information, so it will learn whatever is available. There is no diversity. Yes. If you have large amount of data, see why we need machine learning, deep learning concept and all. If you have, because nowadays data are accumulated, yes, larger in nature, right? So to handle large data, with the help of large data, what I can do? That is why machine learning and deep learning comes into the picture. Yes? Right.
Yes. Sir.
Yes.
Good.
So this is about the first challenge. You should, for learning purpose, you should provide more sufficient data for, especially for training. Yes. Yes. So these all are the data pre-processing technique. Let me explain one by one. The very first one is data aggregation. In Python, I hope you all know the group by method. What is group by? We are trying to aggregate based on some condition, right? So that is called that is called aggregation, data aggregation. In Python, we have a group by method. What suppose if you have a column called color and value, randomly arranged values here, right? If I ask you to group based on the colors, then you will get this. This will be splitted into white category. Yes, grouped as white category, red category, and black category. Yes. Now, after splitting, after grouping, what I can do? I can adapt any mathematical function. Yes. I can check the average, I can check the minimum value, or I can check the maximum value. It's very simple. See, you have city name and temperature, right? City name, for example, just give me some cities. 5 to 7 records, please. Or three cities.
Chennai.
Two cities. Okay, Chennai. Bangalore,
Mumbai.
Chennai. Okay, Chennai, Bangalore, Chennai, Mumbai. Yes, and I have Mumbai also. One more Mumbai, right? 1, 2, 1, 2, 3, 4. Okay, fine. 35 degrees Celsius, 25 degrees Celsius, 27 degrees Celsius, and 40 degrees Celsius, right? And 38 degrees Celsius, 40, 48, right? If I ask you to group based on the based on the city, how do you group it?
Will
With
be
respect
like,
to
okay,
Chennai,
Chennai, Bangalore, and
Chennai,
with
Mumbai.
respect to Chennai, you will be getting 35 degrees Celsius, and then 38 degrees Celsius, and then 40 degrees
40
Celsius. And what about Bangalore? Only
will be
two, right?
20,
25
25 and
degrees
20.
Celsius and 27
And
degrees
yeah,
Celsius. For Mumbai, 40 and 48 degrees Celsius,
48.
right? So
48.
with this, what I can do, just assume these informations are past week weather report, right? Okay, with this information, how do you interpret? Okay, last week, the highest temperature is 40 degree in Chennai. Yes, we can interpret, right?
Yes.
Yeah, how do I know 40 degree? By using some, after grouping, you are supposed to apply some mathematical function. It can be a min, or it can be a max, or you can compute median, average, mean or median. Yes, you can even compute all statistical stuffs. Yes, so that you
Yes.
can interpret the result. So that is why we need data aggregation, especially. Yes. for prepare while doing the
Ma'am,
preparation.
one question. Hello.
Yes, yes.
Yes, ma'am. So here in this scenario, how do we decide which value to select? So suppose you just mentioned about min and max, right? So
Mhm.
based on what criteria we proceed with, should we select min or should we select max?
Ah,
Apart
it
from
depends on
provided
the
we have.
query. It depends on the query, right? See, you are a data
Mhm.
analyst. You have a
Mhm.
data based on the past previous record, historical record, right? If I as a like that a lead or a team lead or whatever, right? So if I ask you to compute or if I ask you to check the highest degree for Chennai, highest temperature for Chennai, just list out the highest temperature for Chennai, Bangalore, Mumbai. But see, here it's only 7 records. Just assume you have 7K records in your data. Yes. So this aggregation will help you to understand. Yes or no? Here you can check
Mhm.
one by one and then you can do it. But it's practically it's not possible, right? If you have 7K data
Mhm.
or 10,000 records, right? Past week means like city wise or past. It's not like a past week. Even you can also consider 1 month records. If you have more
Got it.
records, then you have to do aggregation and then only you can adapt min or max. If I ask you to check the minimum temperature, then you should take min. It depends on the query, right? Even I can ask you to check the average temperature for the city Chennai city temperature, or you can even I can ask you to compute the average temperature for Bangalore, for Mumbai, right? In that case, you have to the suitable method you should know. Yes,
Mhm.
this is about
Got it.
data aggregation. And what
Ma'am,
about
I was
and
sort of thinking more towards like I have one scenario in my mind. Suppose like there's an ad agency
sorry,
which uses this data to run an air conditioner ad. Hello,
your voice is
hello,
breaking.
am I audible?
Hello? Yeah, your voice is breaking. Hello?
Just am I audible now?
Yeah, you are audible now.
Hello,
Yeah, you're audible. Hello, can you hear me?
just
Hello?
Yes, ma'am, you are
yes,
audible.
yes,
We can
yes,
You are,
yes,
we can
madam, you
hear
are
you,
audible.
ma'am.
we can hear you.
So, ma'am, I have one query where suppose there's an ad agency and
Okay.
they sort of want to use
Hmm.
this data to decide whether to run an air condition ad or not based on the city.
Yes.
So, in that scenario, so here,
Hmm.
what would be the best? Like, should we go for max, median, mean? Like because data will be distributed over like a couple of quarter or say couple of years just to check the trends.
Yes. But you should clearly provide your input feature, then only I can answer this.
Oh, okay. So in each
The
and every
feature is
scenario, it
important.
totally
Here
depends.
I have given these 2 columns, right, as an input feature. Just list out your features, then I'll answer.
Oh, okay. Got it. Got it. So in
It
each and every
depends. It
scenario,
depends
it's
on
like.
whatever is having in my hand. Based on that only you can answer.
Okay. Okay.
Hmm.
Okay. Got it. Yeah.
See, if the questions are not relevant to your whatever is available, right, as a data, then we cannot answer it. But we somehow we can try to extract the information. For example, by doing or by calculating. See, it's very simple. I'll give you one more info. One more. See, the thing is, what suppose if I have employee ID as one column, yes, and name of the employee, yes, and date of joining, and we want to predict based on my based on the company record, we want to predict how much percentage they will get the hike. Yes.
Mhm.
In order to get this hike, in the past previous record, the one important information is what? Experience.
Yes.
Not always, but
But
just a
yeah,
traditional way.
yes, we
Traditional
can
way.
say that. Yeah. Correct.
Traditionally, we can say that. Right. We based on the number of years. Based on the number of years.
Government job, ma'am, right?
Okay. Yes. Okay. Okay. You can also consider experience or skills or number of projects completed, whatever. But I will proceed with the traditional. Then it's easy for me to explain. Nowadays, it's very complex, right? Yes. So this information is not at all available in my data. Yes or no? Will you accept this?
Yes. Correct.
But what I can do with the help of data of joining, I can compute it using some mathematical calculation, right? I can compute the experience as on till date. Is this acceptable?
Yeah, makes sense. Got it.
Yeah. Yeah. So in that way, I can proceed. That is why we need a data it's not comes under pre-processing, it's a feature engineering. That is what our next discussion. Okay.
Understood.
Yeah.
Thank you, ma'am.
So aggregation is over. Moving on to the cleaning part, right? Suppose if the records are corrupted or invalid values or null values, right? Is it possible to remove, will you accept, is it okay to remove the entire duplicates or null values or noise or errors or outliers? See, noisy means which can contain an exact noise or errors or outliers, right? If salary is -10, then it's an error, right? What is inconsistency? Just now we saw, right? The transaction ID is same, but in one column, the marital status is married, and another column, in the another record, the marital status is single. These two are inconsistent data, right? Yes. See, this can be also inconsistent data. Age is 42, but how it become the date of birth would be 3rd July 2010, right?
Yes.
So these all are inconsistent data. And okay, fine. So we have these many issues in the data. My question is removing record, whether it is a feasible solution or not.
No.
No. Why?
No.
Naturally, the
Size
data
of
will
sample
not
could be very big.
Yes.
Yeah, we can ask
Yeah.
for the
Yeah,
updated
there are multiple scenarios involved here. As per the use case 1 or scenario 1, just assume you have 10K records. Out of 10K records with 4 features. That is, then your matrix will be 1, 2, 3, 4, right? 1 to 10K. This is what your input raw data, right? Out of this, if you have very minimal null value or duplicate is minimal null value or duplicate values are minimal. For example, only 2 records are duplicates, right? Only out of 10K records, only 100 records or records are having null values. Likewise, minimal value, then without spending more time, right? Without spending more time, what I can do? I can simply remove it.
Remove the records.
Remove it, right? Because we have large sufficient data. Removal of 100 will not give any impact on this, right? In the scenario 2, you have only 100 records. Same 4 features. 1, 2, 3, 4. But records are 1 to 100. Out of this 100 record, what suppose if 20 records are duplicates, right? Duplicate, just remove the duplicate concept, right? If what suppose if 51 records or records are having null values. Is it possible even 20 records are duplicate? Will you remove this? After removing, your size will be only 49 records. You will be having only 49 records. But as per the training, the benchmark or the constraint for training is you should pass more amount of data for learning. More data is required. Yes. Yes.
Yes.
And one more important thing is because of one missing value, you have 4 features, right? Feature 1, feature 2, feature 3, feature 4. Because of this missing value, one missing value, you missed these potential information after, because if you are trying to remove the record, yes, you missed those potential missing, potential informations. Yes or no? Will you agree this?
Yes, ma'am.
Yeah. So in this case, depends on the scenario. The action should be taken based on the given scenario as well as the domain understanding, right? So here you should not remove. If I'm not supposed to remove it, then what I can do it? That is what our next discussion in the data cleaning process. We can impute the missing values, right? We can impute the missing values by inserting some records, right? By inserting some values, right? Either if you don't want to take any risk, instead of representing the null value, you can replace with, if it is a numerical value, right? If it is a numerical, you can replace with 0. This is one approach. Okay. And otherwise, but if you have a domain understanding, right? If you have help from, you can take, you can also take help from domain expert, right? So in that case, you can replace the value with last known value. What is last known value? In the previous record, the value is 129. I can also provide 129. See, again, the approach depends on the scenario. Just assume it's a, what suppose if the scenario is loan approval scenario, right? The loan amount requested loan amount is 1 crore for the previous record. Is it possible to keep the same 1 crore for the second record, the missing record?
No.
No.
No, right? Yes?
No.
Yes? Right. Okay, fine. So for this case, just assume the price, the column is price, right? So in this case, what I can do, I have some 112 amount, 112 some values. Is it possible to keep price as 0 for missing value?
No.
No.
No. No, logically it's not correct, right? So that is what. So you have to do some kind of search and research in this data cleaning process by understanding the problem statement clearly and with the help of domain expert information. See, if you're not aware of the domain, right? If you're dealing with a medical record, then you should take help from the domain expert. Then only you can take decision. Blindly, you should not take any. You should not consider any approach, right? And the best actually, especially for numerical value, the best value is mean, right? So for the entire record, what it will do, it will take the average and it can be considered, it can be replaced as a mean. But one drawback is here. What is that? What suppose, just assume I have 1, 2, 3, 4, 5. Instead of typing 6, right? By mistake, I typed 600, right? Actual original data is 1, 2, 3, 4, 5, 6. What is the average for this? Mean 21 by 6.
3.5.
Sorry?
3.5. 3.5.
3.5.
Yeah. 3.5. Yes, the value is 3. Actual mean is 3.5. Because of this outlier, now you just compute the mean. 15, that is 615. Correct? 615 divided by 6. What's your value?
102.
102.5.
102.
Okay, 102 something above 100. The value is not a promising value. Yes, average should be 0 to 100. By seeing this value itself, we come to know that that is what. See, the adapting technique is very, very important. So if you have outlier in your data, taking mean is not suggested, not recommended, right? So instead, then what I can do, right? If you have a doubt in that, then you can take a median. What median will give you? What are all the steps you are supposed to follow for median? Sort the record, right? Fortunately, the records are already sorted. Yes, 1, 2, 3, 4, 5, and 6. The larger value in the 600. In the last, take the center portion. That is median, center values. You will get 3, 4, right? Right? See, if it is an even number, if it is an even number, you should consider the center 2 number by 2. If it is an odd number, you can take center number alone, right? Yes. So 7 by 2 will be getting 3.5. This is very simple record. That is why this mean is more aligned with your original mean. In sometimes you can get 4.5. 4.5 is better than 1 or 2. Will you agree this? Sometimes you can get 3.1. this 3.1 is better than 1 or 2 because this is more aligned with my data. Aligned with my original environment compared to this outlier data set. Yes, that is why taking mean or median is very plays an important role here. Yes, and interpolate based on the splines. These all are the techniques. Okay, let me start with this. How to handle the outliers. I hope you all aware of box plot. Yes.
Yes.
Yeah.
Yes.
Yes,
Yeah.
ma'am.
Yes. I'll give.
Hi, ma'am. Just one general doubt.
Yes, please.
Actually, I saw some problem in ISM related to this. Like, they give us like sample data and like for example, fat in sandwich, and then they'll
Okay.
ask us to calculate the different like mean, median, whatever, and interpret. Now, for this interpretation part, like you just mentioned, we need the domain knowledge, right? I personally have zero idea of what's the average fat value, whether it's nutritional or whether it's good or bad. So that's not in the question paper I saw. It was not mentioned like which is the right line of value below which it will be less and above which it will be like high or whatever. So it will be usually mentioned the question, right? Or
No,
if it's not
Whether
mentioned, then
whether it is for assignment or
I saw this in old ISM question paper for mid semester. So, and also similar questions in PPTs. So in they just give us the data and ask us to compute mean, median, average. I mean all these, and then draw conclusions out of it or interpretation. So if they don't give us like okay for example BP value should be let's say 120 for a normal human the healthy human being, and if it's high BP then it should be over 200, so I mean 120 or whatever. So these things unless they mention we will not know, right? So we cannot answer these questions in the exam if it's not
the
mentioned.
BP related question, yes, you can raise your concern to the concerned faculty, no problem. But the thing is, the BP related stuffs we know already, but the fat related stuffs, of course, we don't know.
Yeah.
Because how much per, whether it is per meal, meal per day or that conclusion is not. So it should be clearly mentioned in the
Question.
Yeah.
Yeah, right. Okay.
Yeah, you can raise this concern. Yeah.
Okay,
See,
right.
this
Thank you.
is called as box plot. Okay, so I just based on my data, available data, right? I just created this box plot. The actual concept of box plot is, see, are you able to see this box here? This box? Yes. So
Yes.
majority, that is around 75% of the data distribution. What is data distribution? If you have marks like starting from 0 to 95 or 98, whatever, right? For some people can have 21, 5 to 6 students may secured 21 marks, or 10 students may secure 95 students. Likewise, this is what count, right? This is what distribution. Yes. So based on this distribution, here you have a frequency or count. Okay. Based on that, based on this mark value, I have plotted this graph, right? So the thing is, around 75% of the data distributions are fall or belongs to this region. That is the interpretation first. Okay. The box which tells us 75% of the data are distributed between this range, right? What is the range? That is 75%. Just assume for explanation purpose, this is 30. Okay, this is 75. 30 and 75. Okay. Between 30 to 75, the marks, 30 to 75, the values are located here. Okay. Yes. Rest of the values will be laid. Rest of the values can be either upper bound, lower bound or in the upper bound. That is, see, the box plot will tell you actually the distribution of data with the help of this box plot, I can easily identify the outlier, because you can ask a question, ma'am, you are telling outlier, how do I know, how to assess, how I can identify whether the data has outlier or not? One simple visual representation is box plot. After plotting that particular column with respect to x-axis as your column, so x-axis with respect to y-axis, your frequency of the value, right? So after plotting that, you will get this kind of visual representation. I'll explain the terminology first. The center line, it's not necessary that it should be always in the center. Okay. In some cases, the mean can be here. In some cases, the mean can be here, right? So don't fix the mean value here. It can be anything. It can be anything. The mean can be anything, right? So here, the center portion, the center line will tell us the median value, that is 50th percentile, not percentage. This line will tell you the lower quartile or 25th percentile. This line which will tell you the upper quartile, which is nothing but 75th percentile, right? In between, majority of the data will fall under this region, right? That is what our understanding here. Yes. See, there should be some exceptional case, right? Yes, it's not necessary that we cannot say that all students will get 30 marks. Damn sure all students will get 30 or above 30. It's not necessary. There might be a exceptional case, right? So for that exception, to handle that exception, I can have this kind of whiskers, right? So minimum threshold is like this. Minimum threshold is 10. Similarly, the maximum threshold is this point, right? I'll tell you how to compute the minimum maximum threshold of 25th percentile or 50th percentile, right? But try to understand the concept here. Yes, how do you read it or how do you interpret it? That is very important. From this graph, I can say that 25% of data points, in this case, what suppose if it is marks, right? 25% of the marks, 25% of the students' marks are 30 or what? Lesser than 30. Okay, this is how you have to read or interpret. Then what about this? Median will always tell the 50th percentile, right? So 50 in the class, 50% of the student marks are, right? What is this? 55 or lesser than 55. And how do you interpret this line?
75% of student marks are below.
75% marks are 75% of the students' marks are, in this case, 75 or lesser. This is lesser than 75, right? It's not necessary that 75 or lesser than 75. This is how you have to interpret. But the thing is, the maximum threshold is like this. Okay, the minimum threshold is like this. What suppose if the data points are located here? After this lower extreme, what suppose if the data points are located here? These data points are identified as outlier. Is this clear? Yes. This is this is visual representation. So before going to proceed, you should aware of IQR and Z-score method. That is what our discussion in the upcoming slides, upcoming 10 minutes. IQR is interquartile range, right? IQR is nothing but interquartile range. Interquartile mean in the box, you have Q3 as well as Q2 in Q1 in between Q2. This is 25th percentile. This is 50th percentile, and this represents 75th percentile. The range, if I want to check the range between the block, right? Then what I have to do? Interquartile range. Q3 minus Q1. That is what my interquartile range. Q3 minus Q1 will tell you the interquartile range. So in the traditional approach for outlier deduction, right? So, okay, fine. This box can be plotted based on my raw data, right? But how do you expand my whisper viscous towards the lower end as well as towards the higher upper end. So the formula here is, the traditional formula is, you are here, right? Q1 minus 1.5 times of this range, IQR. Yes. And what about this one? Currently you are in Q3. I'm trying to compute the maximum range towards upwards, right? Yes. Then Q3 plus 1.5 times of IQR. Is this clear?
Yes, ma'am.
Yes.
Yes. This is a general formula.
yes,
upper bound and lower bound, right? So if your Q1 is 10, Q3 is 20, then IQR is
10.
this is 10, 20, this is 10, then your
10.
IQR is 10.
10.
Then what would be your lower bound?
0.
Q1 minus 1.5 into
Wo-
IQR.
IQR.
So Q1 is 10 minus 1.5 times of IQR is 10,
10.
which will give you
Minus
Minus
5.
minus 5, right? And Q3 plus 1.5 times of IQR, which will
25.
give you a 20 plus 1.5 times of 10, which is nothing but 15, 35.
35.
How do you interpret this? The values lesser than minus 5 and greater than 35 are called as or considered as outlier.
Yes.
Yes. Is this
Yes.
clear?
Yes.
Yeah, ma'am, if you go back to that box plot diagram, so median is okay, but how did we draw the lower quartile value
Your
and the
voice is
upper?
too low. Your voice is too low.
Ma'am, so median is okay, but how did we come to the lower quartile value and the upper quartile value?
This lower part Q1 and Q2, Q3.
Yeah, how did we reach to that value?
Q1, Q2, Q3. Yes.
Yeah.
All three values. Yes. I have another example. Just wait. Yeah. So here, if I have given some set of data, right? Yes. So find the outlier in the following data. So IQR, there is a formula. But how do I know what is Q1, Q2, Q3? There are two methods. One is interpolation method and another one is a general formula method, right? I'll explain both. Okay. Yes. So as a very first step, immediately you have to sort your data, right? You have to sort your data, compute the median. What is median? Because I know that there is an outlier. I just wanted to check the outlier for the given data, right? It's not necessary that just like that you cannot say that, okay, none of the values are seems like outlier. Yes, but by seeing the value as a human, what we will interpret 10, 11, 12, 10, okay, all values are between 10 to 25. Yes or no? Yes. But our understanding is, okay, none of the values are outlier. Yes. But as per the data distribution, mathematically we should check. Okay. That is why we need this. So compute the median. How do you compute it? In the number of records are 11. Number of records are
12.
12. Okay, I guess it's 12. Yeah, number of records are 12. Hence, what you have to do?
Median
The center one,
6
12
and
plus
7.
13 divided by 2, your median is 12.5. In the box plot, the center line is median, which is nothing but Q2. Yes, for this data, Q2 is 12.5. Is this clear?
Yeah.
Yeah, is this clear? Yes. Then how do you compute
Yes,
Q1?
ma'am.
How do you compute Q1? Q1 is nothing but 25th percentile. Yes, Q1 is nothing but 25th percentile. The formula for quartile formula for Q1, 1 by 4, n plus 1th term. Okay, 1 by 4. What is n plus 1th term? N is
12.
12. So 12 plus 1, right? 12 plus 12 plus 1, 13. So you will be getting
13 by 4, 3.25.
3 point. Sorry.
3.25.
3.25.
Okay. 3.25. What I can say, see, it's 2.25 only, right? You can take third element. 1, 2, 3. Yes. Third element. So which is nothing but 11. Q1. Okay. What about 3 by 4?
Actually, you have to subtract fourth element and third element, then multiply by 0.25 right now, ma'am.
Sorry.
No. For 3.25, you have to take third element plus 0.25.
That is what I told you.
Yes.
There are two approach. One is interpolation or averaging method. You can take your approach is also correct, right? Yes.
Yes, ma'am.
Yes, yours is also correct by using formula. This is another one. Using formula, simple formula, right? But in general, most of the textbook, even for your ISM course or for other mathematical course, they use averaging method, interpolation method. Yes.
Yes, ma'am.
Yeah, that is both are acceptable. That is why I started. There are two methods, right? Yes.
Oh.
Okay.
Okay. Yeah, you can use that also because you know that. That is why I just wanted to explain this formula, quartile formula, right? You can either you can use both, no problem, right? So 3 by 14, you will get the averages like what is this?
9.75.
3 point. Sorry.
9.75.
9.75. So the value lays between 9 to 10, right? See, if you are consider either you can consider 10th element directly as per our approach. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it should be 15. As per approach 1, Q1 is 11 and Q3 is 15. If you are using averaging method, that is 9 to 10. 9 to 10. Both you should consider 9 and 10. That is 14 plus 15. You will be getting by 2. You will be getting 14.5 as your result. For here, if you are using this 3 to 4. Yes, both are 11 only. Still you are getting 11. Are you able to get my point? There are two approaches.
Yes,
one is averaging and another one is as per the formula. Is this clear? Here we are using averaging. Here we are using averaging, but using this formula, you will be getting 11 and
formula,
15.
what is N? Is it total number of
N is
data?
Number of datas, total number of datas. Yes. And we can also use the same.
Doubt. With respect to this n plus 1 or we take n, will it differ based on the even or the odd number of counts?
No. N is total count. How many records you have?
Okay. So this is a standard formula. N plus 1 is a standard formula.
Yeah, standard formula.
Okay.
So ma'am, based on
but my recommendation is proceed with averaging technique.
So averaging technique, you said it is something called as interpolation, right? And this is
Yes.
quartile formula. Okay.
Yes. Interpolation or averaging technique. Yes. The time 10, 11:30. I'll explain this. If you want, you can take. Okay, I'll explain this 6 sigma rule alone. Then you can take 5 minutes of break. Okay.
Can you move back to the last slide? Till we are having our break. Thank you.
Shall I proceed?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
So the next approach is, the previous one is IPR, right? Then the next one is Z score, computing Z score or three sigma rule. So I hope we assumed the data are distributed normally. That is, it uses the normal distribution, which is nothing but mathematically we call it as Gaussian distribution. I hope you all are aware. Yes, Gaussian distribution, binomial distribution. Yes, Poisson
Yes, ma'am.
distribution. There are different types of distribution, but in general, for all data distributions, we assumed our data are distributed normally, right? With a given mean and standard deviation, right? So, for example, this Six Sigma rule, actually it's Six Sigma rule. The 3 sigma rule is based on the properties of normal distribution by considering the mean and standard deviation sigma. Okay, yes. So the outlier can be, see, just assume this bell-shaped curve represent the data are normally distributed. Yes. So if mean is, as per the normal distribution, mean will be 0. Just assume if the standard deviation is 5. What is the representation? What is the understanding here? Data
There is a variance.
variance. Data are from mean with respect to 5 units. Data are spreaded.
Varying,
right?
yeah.
Varied, right? The spread is 5 plus 5 plus 5. Likewise, the data are distributed, right? So if your mean is 0 with respect to 1 unit, how do you compute it? Mu plus 1 standard deviation. Mu, this is what? This one. Mu plus 2 standard deviation. This is mu plus 3 standard deviation. This is for positive side. Same thing is applicable for negative side. Mu minus 3 standard deviation, mu minus 2 standard deviation, mu minus 1 standard deviation. Just assume we have some population and population or sample weights, right? The sample weight of or soap or whatever, some product, right? Just assume the averages, for example, average means mu, right? Mean, right? Average is 25. Average is 25, right? And standard deviation is plus or minus 5. Or even, see, you can consider 250 gram amount, 250 gram weight of soap, right? So if they, in the manufacturing unit, all soap, all the packaging should consist of 250 gram. Yes or no? Yes.
Yes, ma'am.
Yes. That is, but there is a possibility. It can be plus or minus 5 gram. That is what deviation. Yes. Right? So
Okay,
in the quality check, how they will do it? Okay, the average weight is 250 gram, but still I can accept 5 grams. Still I can accept 5 grams plus or minus 5 grams. So as per the normal distribution, how do I assess the outlier? How do I reject the quality? How do I reject the product? Right? So using this 3 sigma concept, you can calculate it. Okay. What is your mean actually? 250 gram. So plus 1 standard deviation, the value will be 1 standard deviation, the value will be
255.
250,
1.
255.
255.
Plus 5, right? Into sigma deviation is 5. 255. And for 2 standard deviation, 260.
260.
Here 265.
265.
That's all. This is the boundary limit, right? And here 245 minus 245,
Yeah.
240,
240,
and then
235.
this is 235. This is the lower bound, right? This is the lower bound and this is the upper bound. That is, the company can accept weightage of 235 gram to
265.
265 grams. So if more than 265 grams, then product,
Then
you will get loss, right?
Rejected.
You will not. Yeah, we
Yeah,
should reject. We should reject and we should repack it. Such kind of decision can be taken here. This is another technique for computing outlier. So outlier deduction is nothing but see the lower bound for lower bound mu minus 3 sigma. Are you able to understand now? Upper bound is mu plus 3 sigma. That is why it is called as 3 sigma rule. Is this clear?
Yes, ma'am. First, we need to check
So,
whether the
ma'am,
data is a normal distribution or not, ma'am, for this to happen.
If the condition is if your data are normally distributed, then you can use sigma, 3 sigma rule.
Okay.
so ma'am, this 3 is a fixed value, constant value, or we can use a 4 or 5, something like that.
Sorry.
In this lower bound example, right? Mu minus 3 sigma. So
Formula
this
is
3 is
fixed.
the
Yeah, formula is fixed.
okay.
3 is fixed. That is why. See,
Okay,
you
got it.
can go maximum. You can go up to this level. 3 steps. That is why.
Okay.
3 sigma.
And
3 is fixed for all problems.
And this is only for normal
In quality check,
distribution.
we discussed. I mean, we have studied about 6 sigma rule, right?
Yeah.
Yeah,
ma'am.
that is what the same thing. Same thing. The entire thing all together, it is 6 sigma.
Ma'am, how to define normal distribution?
By plotting the visual, by plotting the data in converting your raw data into a visual representation, we can come to know about. See, if you are getting bell-shaped curve, it's understood that data are normally distributed. But there is a possibility you can also get more data in the left-hand side. Whether will you consider this as a normally distributed? It's a skewed. Yes, right? Skewed data.
Skewed data.
Yeah, you can also get this kind of very, fewer numbers are larger in nature in this case. This is left skewed and this is right skewed. Yes?
Yes.
Yeah, after plotting, we can easily understand whether the data are normally distributed or not. Okay?
So skewed data will not be considered in sigma rule.
Sorry, yeah, we should not.
Thank you.
So ma'am, how to decide
In that case, we can proceed box plot. Yes?
Ma'am, how to decide like which approach we should adopt, right?
Which?
Approach we should adopt, whether 3 sigma or
That
we have
is
one
what
other
after
approach.
doing in the data exploration is very, very important. That phase occupies more time compared to your model building. You have to do analysis. Okay. Yes. See, I have to finish the syllabus. Please let me finish one topic and then you just ask your query. In between, if you are interacting, since it is a recorded session, it will be difficult for even if you are listening my recording later, then it will be difficult for you to understand. Right? Yes. So you can take 5 minutes of break and then whether we have break. Okay, no break. Yes. So you just take 5 minutes of break and then come back.
Ma'am, only one question, like in the box plot you put, hello?
Yes. Shall we proceed?
Yes, ma'am.
Yes, ma'am.
Yes, madam.
Yes.
Yes, ma'am.
So the next discussion is about okay, like the instance selection and partition, right? So initially we'll be having some, for example, 10K records, 10K data points, right? Sorry, 10K records or 10K data points, right? So we should split the data. We should split the data for training purpose, that is for learning purpose. We should split the data, and for evaluation purpose, we should split the data as a test data, right? For training, we should have more data. That is the logic. For learning purpose, we should have more data. For testing, we can have a minimal data. This is a logic, right? So, but the thing is, how do you sample it? Sampling, there are instance selection and partitioning plays an important role, right? So initially, if you have sampled, if you have 8K records, then this is how the look like of your distribution, right? And after sampling 2000 records, still are you able to maintain the pattern? Yes. And for 500 data, yes, of course, we can. Yes, but it's not dense, but we can draw the pattern, right? So in such a way that you should maintain that the thing is a sample is from the population. If you are trying to take a sample, right? If you are trying to take a sample, is a representative if it has approximately the same properties, whatever properties of interest is nothing but statistically we can call it as mean, median, right? So, or mean or standard deviation or variance, sigma, right? So, all such should be replicated here. I mean, you should retain the same value for the sampling as well. Then only you will get the pattern. Otherwise, you will not end up with this kind of pattern, right? So, these all are the sampling issues. I'll explain with this example so that it will be easy for you to understand. Okay. We have iris data set. How many of you are aware of iris data set?
I don't know, ma'am.
You don't know. Okay, no problem. So you just Google it. So iris is a flower data set. Yes, it has four features, right? Sepal length, sepal width, petal length. In the flower, we have petals, right? Petals, right? So petal length, and petal width. Likewise, we have one more component part which is called as sepal length, sepal width. Based on these parameters or based on this input values, we can categorize the flower, whether the species, see, all are belongs to iris family only. Iris family, right? But this even you just Google it, all flowers will be in the same color, the shape and structure, everything is similar, right? But by understanding the length and width of sepal and understanding the length and width of petal, we can categorize into 3 categories: iris setosa, iris versicolor, iris virginica, right? So in total, I have 150 data records. 50 records belongs to setosa, 50 records belongs to versicolor, and 50 records belong to virginica. Just let me know whether your data set is properly or balanced data or not.
Balanced.
Balanced.
Yes.
How do you identify this?
Based on the count.
Equal number of records in
Equal, not equal. With respect to class, with respect to my target variable, setosa has 50, versicolor 50, and virginica 50. Instead of 50, this is scenario 1. So you can consider this as a balanced data set. Okay. Yes. So what about the scenario 2? Right? Instead of 50, you have only setosa only 30. Right? And this is 10. Rest all others are 110. Yes. Rest all others are virginica. Will you consider this as a balanced data?
No.
No, right? It's not a balanced data. This point you should understand. Okay. While splitting the data from 150 to For example, for 100 for training purpose and 50 for testing purpose. I'm just going to do the splitting like this. 100 for training and 50 for testing, right? How will you split this? If you are using random samples, whether it will ensure each and every categories are equally considered? Random sampling?
No.
No, right? See, if you are doing a simple random sampling, from Setosa, it can take, at one point in time, it can take 20 records, right? From versicolor, it can take, it can take 70 records. From Virginica, it can take only 10 records. Altogether, 100 for training. See, for training, I have sufficient record, but during the sampling, whether it is consistent among all the groups?
No.
No, this issue arises if you are doing a simple random sampling while doing the data split. Okay, but these all are the frequently used sampling technique, but you should be cautious. See, if your variable is not a categorical variable, then you can do a simple random sampling. Yes or no? If it is category, then with respect to each and every category, you should maintain, like for example, 30, 30 or 33, 33, 33, yes, or 33 or 34. This is fine. Yes, we can maintain. Yes. So for that approach, we can, instead of simple random sampling, use the stratified sampling. What the stratified will do, first it will analyze the groups. Is there any groups or not? Based on the group, it will try to extract the information. From Setosa, it will take 30. From vesicolor, it will take 30. From Virginica, it will take 30. Altogether, it's 90 for training and 60 for testing purpose. Okay, this is one type of approach. Even it's not necessary that grouping. Even you can also take the third element or the fourth element. See, from each and every state, you should pick 2 sports person. There is a possibility, right? State-wise sports person, you can pick it. You can select it instead of random sampling. So we can provide more importance for, we can give equal importance for all the states in the India. Yes, while doing the player selection. Yes?
Yes.
Yeah. The next approach is called as clustered sampling type. So in the clustered sampling, what it will do, this is also another important, but see, if you have 100 records, so what it will do, 0 to 10 and 11 to 20, likewise 21 to 30. Likewise, it will group. If you have these many clusters, right? If I ask you to take only 3 groups, what it will do? Randomly, it will take this one, and this one. Right? Again, we are not able to maintain the class. We are not unable to handle the class imbalance issue. Okay, so these all are the sampling techniques. So, what suppose if you have,
ma'am, what is that
Ma'am, what is
simple
difference?
random type again?
Sorry.
Can you explain the simple random type again in the sampling part? The
Simple
first one, I
random.
believe. Yeah.
Okay.
What is the difference between stratified sampling and clustered, ma'am? So stratified is, I mean, fixed. There will be a fixed group, and in clustered, what is the difference between them?
Okay, fine. So in the main thing is, okay, first I'll start with the random sampling. Okay, random sampling means randomly it will select the records. If you have 100 records, then just consider 10 records. Okay, 10 records. What it will do, it will select randomly 5 to 7 records. Random, irrespective of the class target variable. If you have yes, no, yes, right, irrespective of, without considering the target variable, it will select the record. Is this clear?
Yes, ma'am.
But after selection, there is a possibility all 7 can belongs to yes, or all 7 can belongs to no, or 4 records can belongs to yes, or 3 records can belongs to no, or 5 to 2. There is a possibility. There are multiple combinations. Yes?
Yeah.
But while giving the data to the model for model for training purpose, it should be, the data should be balanced to one. Yes or no? If you are using 10 records, if you are selecting 10 records, for yes, if it is 5, and for no, if you are selecting 5, then the model will understand the pattern behind the no concept as well as yes concept. What suppose if you are giving nine records for yes and 1 record for no, there is no sufficient information for understanding the pattern behind this no category, right? It's an issue, right?
Yes, ma'am.
This is called as class imbalance issue, right? So that is why we won't accept random sampling if your categorical, if your values are categorical in nature. Okay. And to overcome that, we can have stratified approach. So what is the, okay, your question is, what is the difference between stratified and cluster approach? Yes?
Yes, ma'am.
Yeah. So in the stratified, what it will do, it will consider the target variable. It's very simple, right? Yeah. It will consider the target variable y. In this case, for example, if yes and no, with respect to yes and with respect to no, it will select equal amount of record for yes as well as no. Okay.
Okay.
Okay. Then what about the cluster? See, it's simply divide the data into a meaningful group. Okay, but then only it will take a sample from every group. That is the concept. From CSC, see, it's very simple. If you have 3 departments, CSC, ECE, yes, IT or mechanical, from CSC, we are even, so the total count is 400 and here 380 and this is 280, yes. But using the stratified sampling, from CSE it will pick 100, from ECE it will pick 100, and from IT it will pick 100. This based on group wise it will pick. This is called as stratified. And what about cluster?
It will pick 2 groups, CSC and DC, leave the IT.
See,
Just
the
an
thing
example.
is, what it will do, it's very simple, only one difference. In the stratified sampling, it doesn't care about the natural groups, or natural clusters, right? Even though if you don't have Y, we will discuss this clustering part later, right? Even though you don't have Y, based on the records and based on the similarity, doesn't care about the patterns, like existing natural pattern, but the cluster group is naturally, it's a naturally existing group in the population. Okay, from that population, we are trying to see, I think we have one sample here, right, in the outlier concept, one diagram. Yeah, see, these all are naturally formed group. Yes or no? Yes.
Yes, ma'am.
From here it will pick 50. From here it will pick 50. From here it will pick 50. And from here it will pick 50. Yes, that is called as cluster. So, which divides the population into groups.
This is not stratified, ma'am, because stratified means we will first identify the groups and then pick equal number of samples from that. That's what I understand.
No. See, it's very simple, ma'am. The thing is, okay. So here the groups are in stratified sampling, it will take a strata. Group name is strata, right? In the cluster sampling, we will call it as clusters, right? The selection, the selection purely depends on the sample will be selected from every available group. From every available group, right? Selects only some groups. Okay. In the previous diagram, like we have these many natural cluster, right? From these many natural clusters, if you are considering all the cluster, then it is stratified. Is this clear?
Yes, ma'am. Yes.
The clustering means it's not necessary that I should consider all the cluster. What cluster will do? It will randomly pick. See, out of 4, it can take 100 from first cluster and 100 from fourth cluster.
Oh yeah, I get clustering. It will choose the strata itself randomly and then choose data from that.
Yes, that's
right,
it.
Right.
Okay. Yes. So it's 12 o'clock. Till 12:30 we have class, right? At least I'm supposed to finish this feature engineering.
Ma'am, one question. Shouldn't we pick sample data from each group in the same proportion, right? As that group's percentage in total population?
Sorry, come again.
Shouldn't we pick the sample data from each group in the same proportion as the group's percentage in the total population, right? For each group, whatever
Yes,
total
that
percentage
is
of that.
recommended. That is recommended. Then only model will learn properly. But I just wanted to inform you that there are multiple strategies are available: random sampling, strategical sampling, cluster sampling, right? So whichever is suitable for your problem statement, you can use it. That is what again depends on the target variable. Okay. And the next thing is we are entering into the next phase, which is called as feature engineering. I'll explain the feature scaling first. Normalization and both normalization, standardization, both are like what similar, right? I'll first explain why we need this normalization and what is that standardization first. So okay. Just assume I have height as a one of the feature, right? And weight as another feature. For the same person, I have BP level, and I have diabetics. What is that? The value before fasting, after food.
Sugar less than 140, ma'am.
Glucose level. Yes. Yeah, I got it. Glucose level, right? Yes, I have these many features in my record. Can you give me some values for record 1 and record 2 for this? Height could be
160 centimeter.
170.
okay, 160 centimeter or 170 centimeter. Weight can be
60, 80.
60,
60 kg or
80.
75 kg. Yes. BP
130.
125.
120. Because we know the normal is 120. It can be 140. And glucose level
180.
100.
130.
150.
100. Then larger value is
180.
180.
200.
Huh?
200 plus.
No,
Worst
just say
case
200.
340. Can we have 340 as a worst case?
Yeah.
Yes,
Yeah.
we can.
Yeah, we can have, right? Yes. So the thing is, the value ranges for height, if you are using the unit associated with height is centimeter. For weight, kilogram.
kg.
For BP, some unit is there, and for glucose level, there will be some unit. Yes.
Yep.
Will you consider this 75? See, in order to assess the health condition of the patient, is it possible to check? Okay, I have this much BP, 140, right? 140. 140 is lesser than this 340, so I can declare the patient is healthy patient. Is it possible?
No.
Is it possible?
No.
Why?
No.
Different units, different parameters.
Yeah, different units and
Different is
different
different.
parameters, right? Different unit. We cannot compare these values. So if you are retaining the same information, it's a mathematical approach only, right? Machine learning is mathematical approach. It will consider the numerical value as such, right? So if you are doing some any matrix multiplication or whatever, if you are forwarding this information as such, then you will not get a promising result. Yes. So hence we need to convert entire column value separately between a common range, fixed range, usually 0 to 1. That is called as normalization. 0 to 1, the range scales from, we are trying to scale down or scaling down the data. Yes. 0 to 1 or -1 to sometimes -1 to +1, right? So the normalization which converts the value into a fixed range usually. Okay, ma? So what about this? I'll explain normalization first. That is what explained here. Yes. So we should convert this entire numerical information into a fixed range of values, right? So for that purpose, for normalization, we can use min-max normalization. The formula is x here actually v, right? The updated value is actually it is x. So for example, if you have x as your height, yes, 170, 160. Likewise, if you are having something and the maximum value is 170 and minimum value is 130, just assume, right? So how for each and every record, you have to convert this 170 into between 0 to 1. How do you do it? Using this formula, right? Take the first value 170 x, that is b, minus for this column, what is the minimum value? 130 divided by maximum is 170 minus 130. What you will get? For max value, which will be 1. For min value, you will get 0. You can do it. Yes. For 60, 160 minus 130. Yes. Data point minus min divided by max is 170 minus min is 130. Yes. You will get 30 divided by 40. 3 by 4, which is nothing but 0.75. This is how the data values are converted. Is this clear? Yes?
Yes. Ma'am, I have one doubt.
Yes.
Where we can choose the range is 0 to 1 or -1 to +1.
Sorry? No,
In previous slide you told
that is what it's a practical implement. You have to do it practically. Yes, it depends purely. See, we cannot have any concrete answer for all ML related question because the technique, adapted technique, whatever technique you are going to adapt is purely based on your data set. You have to sit and explore, right? We don't have concrete. We can say that these all are the techniques, most oftenly used technique, but I don't know whether this is more suitable for my data or not. Yes. So you have to do the exploration, and after preparing the data, try to build the model and compare the result accuracy. If it is not sufficient or if it is not in the promising level, then you have to redo your research work. This is how we can learn.
Yeah, okay, ma'am, yeah, got it.
Yes. So the next approach is standardization. Standardization is nothing but Z score or
Ma'am, can you please explain min-max normalization? So that first statement, what it is written, min-max normalization to new min, it is underscore min, it is just a variable you're defining, right? New min and new max.
value, new min value, new max value. I just want, don't get confused. It's very simple. The formula says, right? So for easy understanding, what you can do, you can use x min minus x max divided, sorry, x minus x min divided by x max minus x min. If you are considering glucose as your feature, yes, what is max here?
183.
197.
197.
197.
Minimum value?
Yeah, 197.
Minimum value?
78.
78.
This is what your x max and x min. Is this clear?
Yes.
For this column? Yes. Now take one by one. For this small x1, right? x1 minus capital X min divided by capital X max minus X min. This is min max scalar, right? What is your small x1? 148 minus 78 divided by 197. Can anyone please simplify this? 97 minus 78. After simplification, what you will get? Sorry?
119. No,
Huh?
no, divide.
0.588.
0.
0.
588.
58. Okay, ba? Now this is going to be converted, replaced, or you can have a pre-processed column, glucose pre-processed or normalized data as 0.58. Are you able to get it now?
Yes, ma'am.
Yes, ma'am.
Likewise, for each and every record, it will do the min max. And now after doing, you can see the data. Now the ranges are between 0 to 1. Okay.
Yes, ma'am.
Yes.
Yes.
Right.
Yes.
So we have
ma'am,
standardization. Yes.
So ma'am, for normalization, min-max normalization, we have to do for all, like that x1 minus this and x2 minus this, like that for all we
Yes,
have to do.
yes. Then
Okay.
what is this question? Huh? Because we should normalize whatever values we have, everything should be in a fixed range.
Okay.
Record by record, you have to do it. In coding, we have a simple method. By calling a simple method, you can do it. Okay. Please hold.
And this is a simple
Please give
formula.
me
Why
10
they are
minutes
using?
of time. At least I should finish this pre-processing. In the next class, I can proceed with the linear regression, right? Give me 10 minutes. And then the next topic is, so next class onwards, I'm going to mute everyone. Okay. Every 15 minutes, and I will unmute you. If you have queries, you can ask.
Yes, ma'am. Sure, ma'am. Yes.
Because see, I understood, but it's more interruption. The next thing is Z score, right? Z score is not, it's not a normalization technique, it's a standardization technique. Okay. So see, you can ask the question, when can I use the normalization? When can I use the standardization? So we know that minimum and maximum values are known. From the column, if you are able to extract the minimum and maximum values, for example, for marks column, we know the range, right? The minimum is 0 and maximum is 100, right? If you know for sure about the minimum and maximum range, or if the data is approximately uniformly distributed, that is, all values may be reasonably spread between, if you know for sure. How do I know? Doing the exploratory data analysis, just plot the data, then you can come to know that, right? Between, for example, the ages between 18 to 60 only, right? So the algorithm does not assume a normal distribution. In that case, if your data are not normally distributed, right? What are all the assumptions I have given? If you know for sure about min and max, and if the data are fairly distributed, uniformly distributed, reasonably spread between 18 and 60, right? So in that case, you can use a normalization technique, but normalization is sensitive to outlier. That you should understand. Okay, I'll tell you, I'll discuss this later in the upcoming session. Normalizations are sensitive in nature. It's very simple. What suppose if you have, instead of 189 or 197, by mistake, if I put 1970, it's an outlier, right?
Yes, ma'am.
If you are using this as your max, whether will you get a proper range? No. This is called as, which badly affects the scaled value. So that is why normalizations are sensitive to the outlier. And what about the standardization? Standardization just converts the value to the data by assuming the mean is 0 and the standard deviation is 1. By assuming mean is 0. It's very simple. If your data are normally distributed, then you can, instead of normalization, what you are supposed to do? You have to do the standardization. Okay. So based on, just take the same new value, for example, 180, 160 or whatever, right? For this record, for the entire column, compute the mean. For the entire column, compute the standard deviation. Substitute it, you will get the value. Now, the range is not between 0 to 1 or even -1 to +1. What would be the maximum range here if you are using the Z score or standardization?
1.
No. See, the value is 1.25. Normal distribution. Acceptable ranges are -3 to +3. Got it? That is what we discussed, right? C 3 sigma.
Yes, ma'am.
Okay. So these all are the additional examples. You just see here. This is visual representation. Actually, data are plotted here. After normalization, it will be from 0 to 1. Scale down, right?
Yes,
Even
ma'am.
after standardization, by considering the mu and standard deviation, the data are plotted like this, right? These two steps are very, very important in feature engineering or feature tuning, right? And one more important thing is in the in the previous 10 to 15 minutes back, we discussed one use case, right? The WLP students dissertation information, whether they are eligible to apply the dissertation or not. If I ask you to predict it based on the given information, name, gender, age, date of birth, organization, some courses are there, right? So see, first semester you'll be having 5 courses. The second semester you'll be having 5 courses. Third semester you'll be having 5 courses. Then only I'm trying to check whether they will eligible for fourth or not. Yes, yes. So much of features. Feature 1, feature 2 till maybe feature 50 or 60. This kind of data are called as high dimensional. The dimensionality is higher in nature here, right? The dimensionality is high. Your data are high dimensional data, right? Is it necessary to consider all a feature?
No.
No. We can remove the unnecessary or non-promising information from the data set. That approach is called as feature engineering. So feature extraction, dimensionality reduction, feature selection. You have to select the most promising or useful features, and even you can construct the features. Like for example, I told you, right? Based on the data of joining, you can construct what? Experience. Based on the date of birth, you can construct the age, right? Based on the 5 subject marks, 4, 5, you can construct average. Yes, instead of considering 5 columns, I can come up with 1 column, right? Semester 1 average or CGPA. Yes. So these all are called as feature construction. You can also do the feature transformation. That is what our next discussion, right? So in order to reduce the dimensionality, we can extract the features. Okay. Yes. So the solution is, we will discuss this in the upcoming module, principal component analysis, which is nothing but dimensionality reduction. Based on the importance of feature, we will select the best features alone, right? It's very simple. Whether these features are, these features impacted, whether these features are more important to in order to predict my target variable y or not. That is the understanding, right? And even we can also use subset of remove the irrelevancy. Name is not necessary. Gender, age, date of birth. Whether these features impact the question, whether the student will get will enroll the dissertation.
No.
Is this no? Organization, job title, nature of job, entrance score, eligibility, no, right? Yes.
Yeah.
The sections, but the main important information here is a subject score, because that criteria threshold is 5.5. You should secure 5.5 in each and every semester, right? So the attribute of interest from the previous degree, you can get SEM 1 total, SEM 2 total, SEM 3 total, and CGPA, or is eligible for dissertation, right? And
yes, ma'am.
I mean, sorry, if these attributes are more than sufficient, whether you have cleared previous degree or not, we need to check. And semester 1 total, semester 2 total, semester 3 total, CGPA, this is acceptable, right? And another set of attributes are previous degree, whether they have completed. Instead of considering total, you can also use GPA. Yes, final CGPA and eligible for dissertation or not. Yes, whether they have completed S1, S2. See, I have given 3 set of attributes. Depends on the condition or policy of the WLP. You can use any one of the scenario. Yes, but this is not acceptable for us. Why? Even though you have completed semester 1, what suppose if your percentage is 5? Whether they will allow you to proceed with the dissertation?
No.
No. Yeah. But in some cases, some company or sorry, some institute, they can have their own policy. In that case, you can use it. Okay. And the next thing is this is about the discretization. Okay. What is discretization first? It's a binning concept. Are you aware of it in your parallel course ISM?
No, ma'am, not yet.
Not
Not
yet.
yet, ma'am.
Not yet.
Okay, binning is nothing but it's very simple. I'll take one slide, one empty slide. I'll explain two types of binning instead of this theory. Okay. Yeah. Okay. Yes. Just as you might have a records or data or mark, whatever, right? 30, 29, 8, 21, 20, 2, 0, 29, and 20, 10, for example. This is what my initial raw data. Yes, you can do the binning. Binning means like from 0 to 10, how many records are there? See, you are plotting this, right? The graph visual representation like this. Yes. So 0 to 10, what suppose if you have 10 records, which points 10 here? 11 to 50, if you have 50 records, then which it should it should be mapped with 50 count. This is frequency, right? It's nothing but a density, probability density function or a PDF diagram or histogram, right? So in the visualization part, you can have a idea about this, right? So it's very simple. Once you have a raw data, how do I know whether 0 to 10, one binning, one range, 1 to 50 another range, or 51 to 100 another range? How I can proceed with this approach? You can use two types. One is equal with, yes, equal with partitioning. Yes, what it will do? First, it will sort the data. So after sorting, you will get 0, 2, 8, 10, 20, 21, then 29, one more 29, 30. Yes, right? If you are partitioning the data equal with partition, right? Then this is the formula. Width can be calculated based on max minus min divided by k. Here k is how many number of groups or how many number of bins. See, here you have continuous data. I just, instead of considering the continuous data, I just wanted to group together, right? How many groups or how many bins are needed, right? If I want to group it as a three groups, then what you will get? 30 is the maximum, 0 is minimum, divided by 3, you will be getting 10 as your result. Yes? Yes? Then how do you group it? How do you group it? So 0 to first bin starts with 0 to 10, and second bin 2, 11 to 20, and then 21 to 30. I think that's all, right? Yeah, bin 3. Yes. How many records comes under 0 to 10 category?
4.
4.
0, 2, 8, and 10. 4. Yes, 4 data points. And then what about your 11 to 20?
1.
Only 1, which is nothing but 20. Yes. What about this one? 21 to 21, 29, 29, 30. So in total, it is count is 4. This kind of discretization, see, it's a continuous value. I'm trying to discretize in nature. Okay, I'm trying to discretize it using equal with partitioning, right? But another approach is available, which is nothing but equal depth. In this case, here the number of count is 4. Here also number of count is 4. Here also number of count is 4. What is the meaning of equal depth? If I want three records, then what the equal depth will do here? very simple. 1, 2, 3. That's what, right? Yes.
Yes, ma'am.
In
Yes.
bin 1, you can have 0 to 8. Bin 2 can have 10, 20, 21. Bin 3, you can have 29, 29, 30. It depends. It depends. Whichever is suitable for you, you can proceed with that. Okay. This is about the discretization, a binning concept. Okay. Again, this is more straightforward, but if you have outliers, because we are using max-min concept, right? Whenever we are trying to use max-min, try to identify the outlier, remove the, handle the outlier using the more suitable mathematical technique and then proceed with this approach. Okay. So these all are the feature engineering concepts, and even this is the last discussion. Even we can do the whatever we have discussed so far is majority we have discussed about the numerical values, especially continuous numerical value. If your values are categorical in nature, how do you convert it? I have car type, yes, feature 1, and fuel type, right? There are 4 models, A, B, C, D. And fuel type, gas, diesel, gas, and gas. There are 2 categories for fuel type and 4 categories for model type. Yes. So the car and gas can be converted into, because system doesn't understand about this natural languages. We have to convert, we have to do the encoding, word embedding. The technique is called as word embedding. The text should be converted into a vector, which is called as word embedding. So for that, we can use one-hot encoding or normal label encoding. Label encoding is very simple. How many categories are there? Based on that, it will label it. It can be 0, 1, 2, 3. Yes, this is label encoding. What about one-hot encoding?
Wherever it is there, like gas, it is
Yeah.
one, and
So
diesel,
in
it is zero.
total, I have 4 categories, right? A, B, C, D, right? With respect to first record, what it will do? In
It
A
is
only, it will
gas,
enable the
Present or
value.
not.
Rest all other will be
zero.
0. This is one approach. This is one-hot encoding. This is label encoding. Here, B should be 1. Rest all other should be 0. For 2, C, here 1. Rest all other should be 0. For D, it should be 1 and rest all others should be 0. This is about label, one-hot encoding, or you can, if it is a binary, you can do the label binary coding, 0 or 1. There are multiple representations, right? So that's all about the module 2. In the next class, I'll start with, I have given self-practice questions and the ML workflow for a few terminologies here. Okay. So before coming to the next class, try to read these terminologies, right? And then come to the class. Okay. The next class,
Okay,
I'll
ma'am.
start with the linear regression. Linear. Yeah, linear regression. Okay,
Ma'am, this
module
deck will be
3.
in SharePoint, right? We can download
Sorry?
from there. This deck
Sorry?
will be in SharePoint. We can download from there and we can practice.
Yes, and I'll
Like other
upload one. Yeah. I'll upload one. IPython notebook for pre-processing for your reference. I'll upload the data set as well as pre-processing notebook as well. Right? IPython notebook as well. I don't have time to discuss it. You just try by yourself, right?
Yeah.
Ma'am, are you planning to take any extra class to compensate the missed
Yes,
one?
of course, I'll take it. Before mid-semester, they will conduct one buffer session during Friday. So that time I'll conduct the extra class. Are you available tomorrow or Sunday? Okay, today Saturday. What
Ma'am,
about your Sunday schedule?
weekend
What
would be
about?
better, ma'am, because weekdays it is difficult to manage,
No.
ma'am.
It's
Yeah,
not from
tomorrow is
my.
good.
It's 1 second. It's not in my hand. But the thing is, as per the policy, if I have cancelled any classes, in common they will conduct one buffer session, right? The dates will be intimated later, even to the faculty as well as the student, right? So that during that day, the all compensatory class will be connected. But okay, before that, I just wanted to know about your availability of Sunday. I'll try
Ma'am,
from my end.
Yeah, Sunday
tomorrow we
evening.
already have a buffer class. Ma'am.
Yeah, we have this.
Not tomorrow, not tomorrow. Just give me your Sunday schedule. Not tomorrow.
Please,
Tomorrow is
should be
Sunday.
fine.
Sorry, next week or later.
Should
Even
be
June
fine.
first.
Ma'am.
Next Sunday
Week,
is good, ma'am.
Sunday evening, ma'am, right?
One by
morning,
one.
morning 8 to 12:30 we have classes, and then anytime that works for you.
Okay, morning
Sunday
8
eve,
to
ma'am,
12.
right?
Sunday
Yeah.
evening is fine. 2 to 4 is fine, right?
Yes,
Yes,
ma'am.
ma'am. Sunday
Yes,
evening
ma'am.
is
Yes.
fine.
Yeah.
2 to 4
2
is
to 4 because
2 to 4
afternoon,
is fine, ma'am. Sunday 2 to
yeah,
4
6
is
to
fine.
6 to 8 I have class. So 2 to 4 is fine for you. Okay, I'll write mail. Let me check. Okay. June first week I'll conduct the compensatory class if they allowed, if they permitted. Okay.
Okay, ma'am.
Otherwise it will be in the Prof session only.
Actually, there is an assignment schedule that came out for machine learning, and it starts from 18th May, but on linear regression. But we are not covered the topic, right? So how to?
Yeah, no problem. Just wait for one. Okay. Okay. Submission date.
31st of May.
31st May, man. It is put like that.
31st May. Okay, try to finish the pre-processing and all, right? The pre-request steps, right? Next week I'll finish the linear regression. Okay.
Sure, ma'am.
Yeah.
Ma'am,
So
regarding
meanwhile, okay, fine. Meanwhile, if you're not comfortable, then other faculty for post handling faculty recordings are available because they have completed the third module, right? So you just go and refer that. Meanwhile, if you want to finish, okay. Anyway, I'm going to proceed as per the flow only, but still, you are supposed to finish your assignment, right? So if you want to get idea about the linear regression, we have other section faculty courses. I mean, the recordings are available, I guess, right, for all.
Yes, ma'am.
No. Are you able to see other faculty recording?
Yes, ma'am.
Yes, ma'am. We can see.
Yeah. Meanwhile, you can cross verify that. Anyway, I can finish it by next week only, linear regression concept. I'll start with linear regression. In the entire class, I'll finish module 3. Okay.
Sure, ma'am.
Okay.
Ma'am, just two questions from me. Ma'am, one is there are labs. Is it like mandatory?
Which lab?
Lab. I heard there is lab, right? Like this
Okay,
online
labware. Yes. Yes,
lab
online.
classes. Is it mandatory? Like we will have exams in labs? Or
No examination for lab, right? It's for your practice purpose
practice.
only.
Okay.
Yeah, for practice, we have provided the provision in the labware. So
Right.
you
And
can,
a second thing is, ma'am, how will I cross-check my understanding for machine learning? Like so far from your lecture recordings, I've understood certain things, but how will I check myself? How will I test whether I've reached the correct understanding or whatever? So like
why
personally
practice?
too.
No, why practice? Yeah, that is why you have to start working on the data. Try to handle, take different data sets, right?
Okay.
Take different data sets, different domain data set, healthcare, finance sector, so that you will get understanding, easy understanding, right? It's experience only. By practice only, you can get a clear-cut idea. Once you see the result, then only you can come to know that okay, this is what this picture says. Okay, this is what my interpretation. Okay.
Okay, ma'am. Yeah. Thank you.
Okay. Yes, you can use ChatGPT as suggested by Shushmit.
Yes, ma'am. I do see those. Yes, thank you, ma'am.
Ma'am, one question on the
It
billing.
actually helps in understanding stuff. So
Yes, of course. Yeah, that is why even the faculty can use it, right? Yes.
ma'am, just one question. So
But one
you
more
said
important thing, if you have pro version, please go ahead. If you have free version, you will not get a more promising result. It's a warning sign.
Pro
Disclaimer.
is free for a year. Pro is free for a year. So
Best thing is textbook. Go and read it. Yes, I have back-to-back classes. Shall I wind up the session?
Sure, ma'am. Thank you, ma'am.
Yes, ma'am.
Thank you,
Thank you.
ma'am. Thank you, ma'am.
Sure.
Thank you, ma'am.
Thank
Take
you.
care.
Thank you, ma'am. Thank you.